In order to check whether or not a table shows direct or inverse variation, we're going to look for a constant of variation, our a value, by doing one of two things. If we divide all the y values by all the x values, and we end up with a constant, the same thing each time we divide, that would show direct variation. I like to think divide, direct. And notice it's y divided by x, just like slope, because really with direct variation, that a value really is just your slope. If, on the other hand, we multiply x and y in our table, and we get our constant that way, we get the same number when we multiply and divide, that would show inverse variation. So we're going to try to divide or try to multiply our x and y values and see which way comes up constant. Or if neither way comes up the same thing, then I guess it shows neither kind of variation. So let's take a look at this first table. Now you're free to try either one first, either divide or multiply first. Because I kind of know the answer, I'm going to just do the one that I know works. So what I want to do first is in this first table, I want to go ahead and multiply all the x's and all the y's together in each column and look and see what happens. So multiplying by 2 by 60 gets me 120. Continuing to do that, 5 times 24 also gets me 120. That's a good sign. 8 times 15 is 120. And guess what? 15 times 8 is also 120. So that's what I meant by we're looking for getting a constant, the same thing when I either multiply or divide. What we just found then, because that did come up the same each time, we found an a value. But more specifically, since we multiplied to do that, what this represents is an inverse variation model. So this table is actually showing inverse variation. If I wanted to go one step further and actually write the equation for this, I could do that. Since I know, or recall hopefully, or go back and watch the video, that the inverse variation model was y equals a over x, and because we've identified the a value by multiplying, I can write this equation to represent the data in the table, y equals 120 divided by x. Now, if you had tried to divide that first table instead, you'd see you would definitely not get the same thing when you divided x by y, so it is not direct variation. Watch, though, what happens again on this bottom table. So on this time, let's go ahead and divide. And remember, we have to be really cautious and make sure we do y divided by x, so kind of flip the numbers in your table. And I'll show you why at the end, why that's important. So going through each one, again, we're looking for a constant. Negative 8 divided by 4 is negative 2. Negative 10 divided by 5 is negative 2. Negative 12 divided by 6 is negative 2. Negative 2, all the way down the table. Every time I divide y by x, I get a constant of negative 2. So once again, I found my a value, and more specifically, because I found that constant by dividing, this table actually shows direct variation. Okay? If I wanted to go one step further and write the actual equation, recall from the previous couple videos that the direct variation model is y equals a times x, or in this case, since we identified a, we could say y equals negative 2 times x. Now, before we look at our application problem real quick, just take a look at what would have happened if you had divided incorrectly. Let's say you mistakenly did x divided by y, which happens a lot because that's the way the table's set up. So doing x divided by y, you get negative 1/2. And negative 1/2, and negative 1/2, and so on. And so what I ask in class is, well, would you have come up with the same answer of direct variation? And the answer is yes, because you did get the same thing when you divided. Where you would have gone wrong, though, is if you had tried to say that that was the a value. We know it's not. We know this is the equation. The equation is not y equals negative 1/2 x. So just be careful about doing that. You will get the direct part right, but you'll get the wrong equation. You may have noticed on the last slide that we had said that that constant that we got when we multiplied or divided should be the same, or it should be really close. Well, in a math problem like the ones we just looked at, it should be the exact same thing. The reason I put or close is for a problem like this. Real life is not pretty and neat and organized. It's often very messy. And so we may not get the exact same a value when we multiply or divide, but if it's close, I'd say that that's probably good evidence that our real life situation could be modeled with direct or inverse variation. So in this case, let's take a look at the data we have. We have the tooth length of a shark and the body length of a shark. And what we're asked to do is determine whether or not this table shows direct variation. The reason I would know to check for direct, even if they didn't tell me, was that I would guess that tooth length and body length, if anything, are directly related. In other words, if the tooth size goes up, so should the body length, which would be direct, not vice versa. I don't expect to see a tiny little shark with gigantic teeth or vice versa. So I'm guessing direct, if anything, that's what this table would show. So recall from the previous screen, we know to check for direct variation, we're going to divide. And specifically, we're going to divide the y values by the x values. In a table, we'll consider the top value the x value. So what I want you to do is go ahead and pause the video real quick and do those divisions. Do each body length divided by each tooth length, and we're going to look for a constant. So go ahead and do that real quick, and in a second you'll see my answers pop up. Oh, and round to the nearest whole number, just to keep things simple. Round to the nearest whole number. So last chance to pause the video before my answers pop up. And so that's what I got when I divided. Hopefully you got the same thing if you did those. And so what I'm noticing is that they're definitely not the same number each time, but they're really close to being the same thing. And so like I said, in real life, we're probably not going to get the same exact answer, but I'd say that, yeah, this is pretty good evidence that there's direct variation. And I'd say something like, you know, if I had to pick an a value, I could, if I wanted to be really accurate, I guess average those together, but I'm just going to kind of go out and with my gut and say the a value is about 120. I know it's direct because I got that because I divided each time. So I'm going to say that, yeah, there is some evidence that is direct variation. We've been asked to go one step further and write the equation for that. So because we know what direct variation looks like, I could say y equals a, which we're going to say is about 120 times x. Or if I want to write it in terms of the problem, the body length of this shark, according to our data, is 120 times its tooth length.